Hello, welcome back to Cracking the Cryptic, and well, an arrows puzzle with a twist today. It's coming to us from Drable. Is that how I'm going to say that? Apparently it is. And I'm taking the opportunity to record this in what I hope is a moment when they have now ceased hammering and sanding metal things outside my window. And it's madness that I should choose to say that, because what greater incentive could the workmen have than to start up again? Anyway, I'm going to see if I can do this before the noise comes back. If it comes back as loud as it has been from time to time, I might actually have to take a break for your sake, but we will see. Let's see what happens. Now, first of all, we have released, of course, Blobs' brilliant oil and water Sudoku hunt on the channel, no, on Patreon. That's where it is, and you can check it out there and have a go at the 10 prize puzzles, and there are 2 bonus puzzles as well. Actually, there's even a mini opener puzzle, so there's loads to do there, and you can get to grips with oil and water, and it's difficult colouring. If you saw my video introducing the series, you'll realise that you're very tempted to make oil blue and water another colour, which it just goes against the grain, doesn't it? Anyway, that is on Patreon, along with all the connections and crossword videos. So do check out all our content there. There's other stuff too, and it's very interesting. And of course, all of our apps, they do feature Arrow Sudoku, which is one of the more popular apps, actually. Some puzzles by great names in that app, and we earnestly recommend it. There's 100 puzzles in that one. It's incredibly good value. It really is. The latest app is Fog of War Sudoku. There are also links under the video to SVEN'S SUDOKU PAD and to all of our merch. So do treat yourself sometimes with that. But treat us by subscribing to the channel or liking the videos. Go on. You know you want to. Right, let's have a look at the rules. So Drable is a new constructor, I think, and this puzzle has an extra rule that is presumably quite important. It's called diagonal drift, and the rules are as follows. Normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3x3 box. Digits along an arrow must sum to the value in the attached circle, so those 3 will add up to the same as that. Now, here comes the extra rule. Within all 9 3x3 boxes, the digits along the 2 diagonals have an equal sum. So those 3 will add up to the same as those 3. And those 3 will add up to the same as those 3, etc. Which is a rule I've not seen in operation before. It's one I've found myself saying this recently. I didn't know you could make a Sudoku grid with that restriction, but clearly Drable knows that you can and has done so. Give it a try on that first link under the video. There's enough arrows, in my opinion, for a regular arrow Sudoku, so maybe this isn't too hard, but you can check the video length if you want a better clue than my hunch. Let's get cracking. Okay, so what I like to do in arrow puzzles is find arrows with 3 digits that have to be different on, and only a circle to put the resulting total in, because those 3 digits have to be at least 1, 2, and 3. Actually, there are arrows like this in almost every box. That's great. I think in all of these circles, yes, literally every one of them, I can enter 6, 7, 8, 9. 1 plus 2 plus 3 equals 6. So all of these circle digits have to be at least that much. This one is the exception. It's only adding 1 cell. Right, where does that leave us? Not very far forward. Actually, where it leaves me is thinking about who was the puzzle. I did an arrow Sudoku on the channel not long ago. Was it by Die Hard? I think it was. Where it took me, maybe not an age, but too long to remember, that in an arrow puzzle where the circles are in different rows, columns, and boxes from the arrows, you're often looking at set theory. However, I'm not sure if I can see where that would apply here. You could, for instance, take these 2 columns, which include a few circles, and measure them against, well, Okay, I'm going to shelve that thought. I cannot see how to use set theory in this puzzle. And I'm going to try and use the extra rule instead. So, digits along... Oh, of course, right. No, this is very important. Okay, let's get the pen tool out and just draw a few lines. So, that diagonal, the yellow diagonal, has to equal the blue diagonal. Let's do the same sort of thing in some of these other boxes. And I think there are 4 particular boxes where this is very interesting straight away. That's what I'm going to claim. Boxes 3, 4, 6, and 9. Because obviously you can see that one of the arrows is one of these diagonals. Now, okay, what I'm going to tell you is that this circle cannot be a 6 or a 7. Right, think about if it was a 6. These 3 digits would have to be 1, 2, 3. But this yellow diagonal is meant to equal the same as the blue diagonal. So if that has to equal 6, it has to be made up with 1, 2, 3. And that would also have to be made up with 1, 2, 3. And that would give us 5 cells, each containing the digits 1, 2, 3. Now that's impossible within a box. So this isn't 6. 7 actually operates on the same principle. 7 is always made up, when it's 3 different digits, of 1, 2, 4. So you'd have 5 cells that were all 1, 2, 4 in the box, and that's not possible. So none of the circles pointing into these X's can be 6 or 7. And now we have an 8, 9 pair in box 5 and row 6. That digit cannot be 8 or 9. And now this arrow consists of either 1, 2, 4 or 1, 2, 3. Adding up to 6 or 7. What other ramifications are there? Okay, I think... Right. How can... Okay, one of these is 8. I was going to say, how can any of these circles be 8? Well, there is an answer, and there is only... Well, there's one way in which it can occur, and that is for these crossing diagonals to be, in one case, 1, 3, 4, and in the other case, 1, 2, 5. Now, where do they cross? 1, 3, 4 and 1, 2, 5 cross at the 1. So wherever you get an 8 in a circle, and we know that at least one of these circles is an 8, you must get a 1 at the crossing point. Now the first thing that's telling me is that at least 2 of these circles are 9s. And there might be a reason why it can't be all 3. I suspect this is going to be the 1 and this is going to be an 8. But let's have a think first. There is something else that is telling me. One of these 2 circles does have a 1 at the crossing point. So one of those 2 cells is a 1, and this now is not a 1. Why can't all of these be 9? Let's have a think about that. That would be 9. One of those 2 would be 9. I don't know, they could all be 9. Okay, what happens? Right. Every 3-cell sum that goes to 8 or 9, where the 3 digits have to be different, must have 2 low digits. In fact, whether you're adding up to 8 or 9, you must have 2 low digits. And low, in this case, I'm talking about 1, 2, or 3. So, you can make 8 or 9 with 1, 2, 5, 1, 3, 4. 9 can be 1, 2, 6, 1, 3, 5, or 2, 3, 4. Always 2 low digits. Now, in all of these X boxes that I've marked, there are 2 low digits on each diagonal. 2 of those 1, 2, 3 digits. And you can't put them there and there. because then the other diagonal couldn't get any. So 1 is always, this central digit is always from 1, 2 or 3. And that is giving us a triple in this column. And it's also, well, whichever one is 3 and whichever one is 2 in this column has a 9 in the circle. I really am getting fixated on this being a 1. I have no evidence for that, actually, so let's forget that. And let's bear in mind that whichever one of these is a 1 could easily have 9 as its circle. Ah, okay, here's another thought. Yeah, this is an interesting thought, I think. The numbers on, okay, how to encapsulate the thought. The numbers on these lines can never be 7, 8 or 9. Because if you put 7 on a 3-cell line, you could add at minimum 2 and 1 and you get to a total of 10. That's no good. It's obviously worse for 8 or 9. So these selections are from 1, 2, 3, 4, 5, 6. If I just colour those for a moment, it's very obvious that in column 7 and 9, we're left with a 7, 8, 9 triple. No, there's more to this than that. Here in column 8, we don't have so many restrictions. However, knowledge bomb time, there can only be 1, 6 and indeed 1, 5 in this column. I mean, and 1, 4, but I don't know if that's so important. Why I'm thinking about 6 and 5 is because 6 has to appear twice in the, let's unyellow those. 6 has to appear twice in the yellow cells. And it's obviously in 2 separate boxes. And that means that in 2 of these boxes, there is a 6, 2, 1 triple, a 6, 2, 1 diagonal in one direction or the other. Now, that can only cross at the 2 or the 1, obviously, with the other diagonal. There is also only 1, 5 in this column, so again 2 of the yellows have to be 5s. And they can only cross. No, that's not true. 5s could cross at a 3, couldn't they? But there are 2 5s. So the 6s will cross at the 1 and the 2. I might just be able to add these up. This is a really weird thought. I mean, I don't know if this is relevant, but I think I have to think quite hard about this puzzle. The total of those yellow cells is 42. So let's think about these diagonals. We know the total of the diagonals because we're going to count these, let's colour them pink. We're going to count those twice when we add up the diagonals. We know the total, that's mad. Right, we know the total, it's 6 times 2 is 12 plus all the yellow cells is 42. The total of all the diagonals is 54. Divide that by 2 and you get 18, divide it by 3 and you get 18. So the total of both diagonals, when you count the central cell twice, is 18, and therefore 9 applies to all of these. That's weird. What a weird way. I don't know if that's the way you're meant to get at that, but it's clearly true. I mean, there must be a way to think about it in that 6s appear in 2 of these crossing points, and 5s appear in 2 of them, and 4s appear in 2 of them. And somehow that must get to the same conclusion. But I got there through holistic addition. these 3 are 9s, because all of these yellow and pink cells twice have to add up to 54. And that means that the 9s apply. Right, this is the 8 over here, so I was wrong to think it was there. This is the 8. That is a 1 crossing point. These digits are 2, 5 on one line and 3, 4 on the other. The other digits in the box are 6, 7, 8, 9. This one can't be 8 or 9. That one can't be 8. Where are we now? Ah, look, there's a 6, 7, 8, 9 quad in the central row. This can't be 1. So, what does that mean? If this is 2 or 3, oh, that can't be 3 because of the given digit. I didn't see that. I've seen it now. Right, so in this one, we cannot have 3 there. So this is not where 2, 3, 4 and 1, 3, 5 cross. That must be happening in one of these boxes where there is a 3 in the pink cell. Oh, that can't be 9. None of these can be 9. They're 7, 8 triples. Okay, let's just get rid of the yellow colouring for now. Let's colour these against each other because we're getting 7, 8s moving around. I don't know how that got coloured. We're getting 7, 8s moving around the grid a bit. Oh, 7, 8 comes out of these cells. They are a 6, 9 pair. If that's 2 or 3, this is a 4, 5 pair. Ah, of course, I mean, I mustn't forget that we've got other diagonal boxes to consider. It's not just the 4 where I've labelled. I mean, let's think about this one. This is very interesting now. We've got a 9 there. I don't see how I can put a 7 here. Yes, the point about these diagonals is, I mean, the central cells have been very important in the 4 that we've looked at so far. Funnily enough, I think in the other boxes, the central cells are totally unimportant. Because whatever that is, the 2 reds must equal the total of the 2 blues. Because if we're going to add those 3 up and those 3, we can deduct that as an equal part of both. And now I think we can't make this a 7. Because that 8 would need an 8 to add up to 16 in blue. So we're going to make that a 6 and this one a 7. And that must be true. And this is now not 6 or 7. This isn't 7 or 9. This isn't 6 or 8. Oh, this is getting something done. 6 isn't in those cells. Oh, and 6, 9 pair makes that a 7. And that's not a 7. And it's not a 9 here, that's an 8. And that's not an 8. And that may be all that does immediately. Oh, that's really weird. There's also this relationship between the red and blue cell there, the difference is 2, and it has to be the same on that side, a difference of 2. And between those 2, the difference is 1, and that has to be the same on the other side of the square. This is going to apply across the whole thing, and that's somehow a little bit weird. But now we somehow have to try and figure out something more. We have to try and figure out what the pink cells are, I think. Although I've got very little guidance, actually. 5's definitely in one of those 2 cells. This central cell is pointless. In fact, let's get rid of those colours now we've used them. This central cell can be anything. It doesn't affect the totalage. And so much for my orange and green shading. This is low when I'd expected it to be high at the start, because it's the same as that digit and must appear in one of those 3. What about this funky arrow and this one? Oh, we've got a 6 there. Didn't see that. So this is a 1, 2, 3 triple. And this is now a 5, 4 pair, and that does nothing here. Oh, it makes that a different flavour of 2, 3 from that. Is that any use? I doubt it, actually. Oh, hang on. This can't be 6. Okay, I'm going to do a bit more colouring for illustrative purposes here. So, if that was a 6, these reds would be 1, 2, 3, because all of these digits would be from 1, 2, 3. So you'd have a full set of 1, 2, 3 in red and a full set of 1, 2, 3 in blue. And these two cells, neither of them could be 1, 2 or 3. They'd have to be at least a 4 and a 5, because they're different from each other. And that would bust this circle, because once you get up to 9 there, you can have anything you like here and it's broken. So that is not a 6. That's simple enough. That's an 8. Well, it's not simple, but it's true. And there's an 8 in one of those cells. Oh, where's 9 in this box? It's in one of those two. Interesting. And can that be 6? That would be 2, and this would be a 1, 3 pair. Suppose it could be. Okay, let's keep thinking about red and blue. I think. No, hang on. Let's look at the high digits. 8 is in one of those two. 8 and 7 can never be on this arrow. Or 9, obviously. No, I don't know. Right, let's keep thinking about this 8 arrow. It's got a 1 on it. That's very clear. 8 always has a 1 on it when it's 3 cells. So that takes 1 out of this cell and its arrow. Actually, that stops this being a 6, because this can't be 6. No, it doesn't, because there could be 1 in the... No, okay, sorry, being silly. I keep thinking of these opposites now. Actually, let's think about that opposites thing. If that was a 1, those two add up to 9, and this couldn't be 9, because those two have to add up to the same. That's slightly interesting. I mean, it doesn't stop this being a 1, because that could be 9, but if that was a 1, this might be 1, 3, 4. And then these two would be a 2, 7 pair. Okay, 1, 3, 4 here would complete one of the sets of either blue or red 1, 2, 3s, and would mean that the middly digit, right, this arrow must have 2 of the low digits on from 1, 2, 3, in the same way as everything else has got to. Oh, hang on, it's the 1 in box 2 is in one of those cells, because there's a 1 in one of those two in box 5. Yes, and that's not a 1, obviously, therefore. Sorry, I hadn't quite figured that out. There's a 1 in one of those two, so the... Now, what does that do? That means... It doesn't mean... Does it mean that can't be 7? If that was a 1, this would be a 2, 4 pair. And if we coloured them blue and red, we'd have a full set of 1, 2, 3, 4s in each of the columns 4 and 5. I don't see... Oh, I tell you what, I've just spotted where 9 is in this box. It's got to be there, because that 9's looking at that cell. One of these two boxes has an 8 in, and one has a 7 in. The 8 is either there or there. And that means you can't have 8 in those two cells. This is quite interesting. I don't know how to depict it, so I'm just going to talk you through it. There is an 8 in this column, and it's ruled out of those two and that by Sudoku. So it's either there or there. Now, in this row, that would make 8 in this box here. In this row, 8 in this box would be here. And one of those must be true. So one of these yellow cells, at least, at most, one of those, exactly one of those yellow cells is an 8. I know it's not neither for the reasons I've just talked you through. And I know it's not both, because that would make both green and orange into 7s, and you couldn't put 7 in this box 6. So exactly one of the yellow cells is 8, and I suppose I could make those blue and say the same thing. Exactly one of the blue cells is 8. And I don't know what that means, but it's true. Okay, let's think about this being a 7, because surely that's difficult. That puts 4, 2, 1 on its arrow, of which this is the 1. And this is a 2, 4 pair. Oh, and then you've got 7 and 1 in the corners, so the other corners have to add up to 8. They would be 3 and 5, because 2's on the arrow. So you'd have 7, 2, 4, 1, 3, 5, 9 here, 6 here, 8 here. What other ramifications are there? Where is 9 in this box? It's in one of those cells. If 7 is there, you've got 4, 2, 1 here. Well, I just worked out this can't be 9. Ah, that's interesting. If 7 is there, you've got to have 1 here, and because of these diagonals being the same, this could never be 9, because 7 plus 1 can never equal 9 plus something. So this can never be 9, because either this is 9, or it's 7 and this can't be 9. So 9 is definitely in one of these two, and therefore one of these two cells. That's quite interesting. Now, if 7 is here, this is 9, this is 8. Oh my goodness, I'll tell you what, I don't think this works. This is quite confusing though. Let me just check this in my head. My head is saying this doesn't work. If this was a 7, so if this dark green cell was a 7, that would be 9 in the box, and that would be 8. Now, we know what effect that has. That makes this 8. Also, this 9 would make this a 9 here. And something really weird has happened now. Something really weird has happened now. And it's happened up here. Well, it's happened very specifically here because of these two cells. Let me explain this. This is mad, but it's definitely right. If this was a 7, you then get 9 here and 8 here. And that's a 7. Where's the 7 in row 1 going? If you've got 7 there and 7 there, the 7 in row 1 is here. But the 9 in row 1, you've got a 9 here. The 9 in row 1 must be here. That's looking at this cell. But what have you just done down here? Once you've made, what was it, this an 8, you know that blue is an 8 down this side, because you know one of yellow has an 8 and one of blue has an 8. So if that's an 8, that's an 8. Now where does 9 go? Remember, we stuck a 9 in here because that's a 7. So 9 can't be there. 9's here. And then this is 9, but we just said that was 9. I mean, I don't know. I'm sorry. I think it's lovely, but I suspect it's not on the solution path. But I can't unsee it now I've seen it, and I'm going to use it. There may be a simpler way of putting that into operation. So do let me know at this point in the puzzle, when I'm 25 minutes in, about 28 minutes, 29 in the video, what would you do? Because I'm probably not taking the right next step, but I am taking a proper next step. I'm saying that this digit cannot be 7, because what that does with 9 and 8 here and 7 there puts a 7-9 pair here. but it also puts 9 here, 8 here, and 9 here, and suddenly you can't achieve this cell because of 9, 7 there. And I think that's crazy. It's definitely true. So I'm going to use it. I'm going to make this dark green cell 9. And that places 9 in box 8. And maybe this isn't actually going to speed things on. Well, now I get a 9 X-wing. The 9s in columns 2 and 3 must be in those cells in row 1 and 9. And that means we've used up the 9s in rows in columns 2 and 3, and neither of these cells can be a 9. So they're both 6. And that's quite a big step forward in the puzzle. This is now a 1, 2, 3 triple, where that's a 2. And 1, 3 sit here. Now, remember this rule about corners of the boxes, which all obey the equal diagonals rule. These two have to be 2 apart, because those two are 2 apart. So that can't be 8 anymore, because this would have to be 6, but 6 has been used in the box. So we get rid of 8 from there, and now we know which of yellow and blue down here is 8, and therefore it's blue up here. I mean, I can demonstrate that by going through green and orange over here. 7, 8, not 8, and therefore 8 in blue here. And that is beautiful. I mean, that's lovely. I really like the way this is unwound. I'm going to uncolour all of those cells, not discolour them. Now, 8 is here by Sudoku. I mean, this must have done a lot of work. 7 is in one of those 2 cells. I'm not sure which. I'm sure there's quite a lot of Sudoku to pick up. Just bear with me while I try and do it. 6, 6. One of those 2 is a 6. This digit is 4 or 5. Now these two have to be 2 apart, and they're therefore odd. They could be 9, 7, or they could be 7, 5. There's definitely a 7 amongst them. And therefore there's a 7 in these cells, and that's a 6, 7 pair. Oh, we've got these blooming other arrows as well, and remember the diagonal constraint in these boxes too. Oh, that can't be a 2 anymore. The pinks are now a chocolate teapot triple. Useless. This became a 9. That's what I was expecting. Sorry, I'm sure there's Sudoku. This can't be a 2 by Sudoku anymore because of that. If this was a 3, that would be the middly digit, and this would be the low one. Not very interesting. 4, 7, 5, 9. 9's in one of those. Okay, I'm not finished yet. Still plenty to think about. Oh, where's 6 in this box? It's not on the line. It's right. Oh, no, hang on. It's in one of those 2 cells. It could still be. Could it still be here? No. 6 can't be there because it would be there as well. And we've got that 6 looking at that cell. So 6 is placed in box 8. And now let's think about the diagonals here. That must be important. Well, there's almost the secret to do here. Do you know the secret? That every box in a Sudoku adds up to the same number. It's always 45. Those 2 add up to 15. Plus 8 is 23. This arrow obviously adds up to 8. That's 31. Take that away from 45. These other cells add up to 14. But these 2 have to add up to 8 plus that. So if that's a 1, these add up to 9, and that's a 5. Well, this is 1, 2, or 3 to allow that to be achieved. That's not all that helpful. This could still be 4 or 5 in this column. Indeed, it's reasonably likely to be that. This arrow cannot be 6, 2, 1. Because this digit would have to be both the 1, which is in one of those cells, and the 6, which is also in one of those cells. Now we've got those 2 6s. So it can't be 6, 2, 1. So there is a 3 on this arrow. It's either 2, 3, 4 or 1, 3, 5. The 3 is in one of those two cells, and those can't have a 3 in. 3 is in one of these 3, but it doesn't have to be there. It could be here. 9 plus what there? Don't know. But that's going to be the same as the total of these two. This can't be a 1. There is no digits that you can add 9 to x and 1 to y and you get to the same total. So this one can't be a 1. That doesn't help. These are from 1, 2, 3, 4, 5. Now, these are also from 1, 2, 3, 4, 5 because we're not using 6 on this line. In fact, that can't be a 6 anymore. 6, that's an X-wing on 6s. 6 is confined to those two, so these can't have a 6. There is a 6 in this group, but I don't know if it's on the diagonals still. Same was true with 3 here. Oh, that's irritating. 1 is in one of those cells. Oh, 7 in this box is an absolute giveaway. There it is. So that's 7. Why can't I see that? So 7 has to be here in box 2. It can't go on the line, same as in box 8. And that fixes 6 and 7. And that fixes 6 in this box. Come on, do something, do something. Didn't really do much. Placed a lot of 6s and 7s, but not all of them, or maybe all 7s. Are they all done? Oh, sorry, I've been in crazy marking mode by accident there. Oh, there's only 1 7 to fill in. There it is. Right, now we know 6 is on a diagonal here. And what does that tell us? It doesn't tell us enough. One of the diagonals is 6, 1, 2. So one of those is a 1 or a 2. That's not telling me whether the other the other diagonal is either 3, 2, 4 and this extra cell is a 5, or it's 1, 3, 5 and the extra cell is a 4. So that is 4 or 5. And that's a pair in the row. And that's weird. This digit is 1 or 2 because it sees a 4, 5 pair. This is 4 or 5 as well, actually. And these can't include 3, so 3 is definitely in one of those. And in this box, that's opposite a 4 in one of those two. Yes, 3 now has to be in one of those. One of these lines is a 3, 1, 4 line. So 4 is in one of those, and now we know this digit is a 5, and that comes off the circle. This digit, by the way, is 1, 3, or 4. That doesn't prove this is a 1, 3, 4 line. That does prove this is not a 1, 3, 4 line, because that would be impossible. So this is a 1, 2, 5 line. Let's put the 5 in, and the 2, and the 1, and now we're cruising. This is 3, this is 2, this is 1. Pinks are done. That's going to be really helpful. This is now 3. We're looking at a 2, 1 pair in those red cells, and that's 4 at the top of the grid, and that places 3, and I can add up this arrow and make that 2. I can put, oh no, I want to put 1 here. And it's gone wrong. It's gone wrong again. This is no good. Oh man. Hang on. Where did I go wrong? So I got to here, and I said that 3 or 4 means this can't be a 1, 3, 4 triple. This has to be 5, 2, 1. And interestingly, I said this had to be the 5. Why couldn't that be the 5? Why have I marked that so low? I don't know. I think this has to be the 1 in a 1, 2, 5 triple. Let's start there. Then do the pinks. I think this pencil mark might have been wrong. But this is a 2-5 pair. Now let's do the diagonal trick. We can't have 8 and 5 because we can't make 7 and 6 in the other diagonal. So we'll do 8 and 2 with 7 and 3 in the other diagonal. And this seems to work better. That's a 4 on its arrow. This 9 can be completed. Let's just do arrows. That 3 is in a 3-1-5 triple. And that's a 6. This seems to work. That's a relief, because I didn't like it when it didn't work. That's become a 3. I don't know if that was the same in the other incarnation. 4 and 5 there. These are a 2-1 pair. Let's forget about them. This is a 3. Okay, that's all right. This is a 2, and that's a 1. And this has to be a 5 now for the arrow. And now these diagonals do add up. 10 there, 10 there. That's a 4, that's a 5. This is better. Oh my goodness, that was an absolute panic. That has to be 9, 4 at the bottom, 9 there. This 1 and 3 are resolved. We even get a 3 in the corner. That's 3 in the corner. That's 3 in the spot. Light losing its religion. And this is a 1, and that's a 5, and we can do this column 4, 5. Now, what's going on here? We've got 9 being made up of a 2, 3, 4. Hang on, no, let's start up here, because one of these is a 6, 1, 2 diagonal with a 2 in the bottom row. So 2 is there, 6 is there. These other 2 cells are clearly 3 and 5, and I can do those thanks to the top row. Now I must be able to say that that's a 1, 4 pair, and this is a 3, 6 pair, and they are resolved by a 6 in the grid. So 3 goes there, 6 goes there, 4 goes there, 1 goes there. Okay, let's get rid of the pink. Well, let's get rid of all the colouring. It's done its lovely job. Okay, this is a 3, that's a 5, this is a 4, that's a 2, this is a 1, that's a 2, 1 there, and a 2 to finish. And let's just check this box, 9 and 9, 10 and 10. Yes, everything has worked. This is right. Oh well, I mean, first solver, because nobody's put in the solution. Okay. Fine, but it will be in when you attempt it. That is a brilliant puzzle. What an extraordinary feat. That is so much not just an arrows puzzle, in my opinion. That is a really clever puzzle. I'm trying to get rid of lines and I'm adding them. Okay, let's just leave that. Thank you for watching. We'll be back with you with another Sudoku or 2 tomorrow. Oh, I should have got rid of that circle, which I don't know when that appeared. But what a brilliant puzzle. Thank you, Drabel. Send us another. That's really interesting. I'm very interested in that step around the 29-minute mark where I stop that being a 7. There's probably a simpler way to do that. Let me know what it is. I will see you again tomorrow. Bye for now.